Section 10.1 is titled Angle and Line Relationships. So we're kind of diving back into a geometry unit a little bit. We'll be working with polygons, more specifically quadrilaterals, and a little bit more with triangles, in addition to the angles and lines we deal with today. So today we're going to work with vertical, adjacent, complementary, and supplementary angles, being able to solve the real world or other mathematical problems that involve those definitions. So there will be several definitions today. My expectation, as always, is that you write down the definition or the vocabulary terms, in addition today to some pictures, because those will help. So the first definition is vertical angles. Vertical angles are opposite angles that are formed by intersecting lines. Vertical angles are congruent. So in this picture you can see two sets of lines. They are two lines that intersect one another, and the vertical lines are the lines that are opposite one another. So angle 1, and we write angles using this little angle mark. It's almost like a less than symbol, kind of close. So angle 1 in this case would be congruent, that's the symbol for congruent, to angle 2. It means they would have the same measure. So vertical angles are across from one another, 1 and 2. You can also see that angles 3 and 4 are vertical angles. So angle 3 would be congruent to angle 4. So vertical angles across from one another, they're opposite angles, and they are congruent. Adjacent angles are two angles that have the same vertex between them, and they share a common side. They will not overlap, and they also aren't necessarily congruent. They can be, but oftentimes are not. So here you can see that angle 5 and angle 6 are what we call adjacent angles. They share this common ray, or side, in between them, and they also share a vertex, point B. So you can see that angle 5 here on the bottom, and if I put a label out here so we can label this angle. Angle 5 is ABD, and angle 6 is CBD. So they share this ray in the middle. Next we have complementary angles and supplementary angles. Complementary angles are two angles whose sum is 90 degrees, and supplementary angles are two angles whose sum is 180. So if you take the measure of angle 7, and you'll see me use the letter M with the angle symbol. That means the measure of angle 7, whatever it is, plus the measure of angle 8, they will add up to 90. Similarly with supplementary angles, the measure of angle 9 plus the measure of angle 10 will equal 180. So the biggest trick with these two is just recognizing or remembering which one's which. So complementary adds up to 90, supplementary adds up to 180. So here we want to find the missing angle measures. We can do a whole lot with angles, lots of problems that can be solved. So remember, intersecting lines form vertical angles, and vertical angles are congruent. So angle X is 110, and Y is 70. So you kind of look across from one another, and those are what are congruent. Next we have two different problems. Please write these down so that you have something to look back on when you do your homework. But if angle A and angle B are complementary, and the measure of angle A is 65, what's the measure of angle B? So the biggest thing to remember here is that complementary means they add up to 90. So we're going to take the measure of angle A plus the measure of angle B, and those equal 90. Well, the measure of angle A we were told is 65. We don't know the measure of angle B. So to solve for that, we subtract 65 from both sides, and we get that the measure of angle B equals 25, or 25 degrees. Now I realize some of you probably could have solved that a lot faster. You just grab your calculator, do 90 minus 65, and you get that the measure of angle B is 25. So I just kind of set up a little bit I set up an equation, and you can do it either way. Now we're going to say that angle A and B are supplementary. So remember, that changes things. Now they're going to add up to 180. So if the measure of angle A is 65, and we don't know the measure of angle B, but we do know that they're supplementary, they add up to 180. So now we're going to subtract 65 from both sides. And the measure of angle B is 115 degrees. So that's 180 minus 65. So you can see the difference between two angles that are complementary and two angles that are supplementary, adding up to 90 and adding up to 180. Next, we want to discuss perpendicular lines. Perpendicular lines are two specific lines that intersect to form a right angle. And so actually all four of these are right angles. So they all measure 90 degrees. Remember that the little box in the corner indicates a right angle. We see those oftentimes when we're talking about right triangles, and you'll see them in today's lesson and in this unit. So perpendicular lines are two lines that intersect to form a right angle. Next we have parallel lines. Parallel and perpendicular often go together. Parallel lines are two lines that are in the same plane that will never intersect. And I've used a little bit of color coding here so you can see the difference. The parallel lines are drawn in red. A transversal is a line that simply goes through two or more lines in a plane. And we'll talk about a transversal particularly when we talk about parallel lines, because a lot happens here with these angle measures. So a transversal is the blue line that will intersect two lines or more in a plane, and in our case it'll be intersecting parallel lines. Now come a lot of definitions. So what I want you to do is first just pause the video and get everything written down, including the figure in the upper right hand corner, because that's going to be important. Then we're going to use these definitions and the angle numbers to indicate some things about these angles. So, interior angles. So interior, hopefully you think of the word inside. Interior angles lie inside parallel lines. So what we're saying in this figure is if we have, let's see, lines A and B, we're saying in this case that line A is parallel to line B. That's the symbol for parallel. So interior angles are the angles that are formed by the transversal and the parallel lines that lie inside the parallel lines. So when we talk about interior angles, we're talking about angle 3, angle 4, angle 5, and angle 6. I'd also like you to write these numbers down next to this definition so that when you look at this figure later you can see, okay, those are the interior angles, how does that match what we're working on? Exterior angles do the exact opposite. Exterior angles lie outside of the parallel lines. So now we're talking about the two angles above the parallel and the two angles below. So that's angle 1, angle 2, angle 8, 7, I'll do 7 first, and angle 8. 1, 2, 7, and 8. Next we have alternate interior angles. Alternate interior angles are angles that are on opposite sides of the transversal, but still inside the parallel lines. Also, we need to note that they are congruent. So again, alternate, think of like opposites, and interior means we're still inside. So we're only talking about angles 3, 4, 5, and 6. But now we want the angles that are opposite of one another. So for example, angle 3 is going to be congruent to angle 5, and angle 4 is going to be congruent to angle 6. So notice how they are opposite from one another. Those are alternate interior angles. Similarly, alternate exterior angles are angles that are on opposite sides of the transversal still, but now are outside the parallel lines. So alternate exterior, we're talking still about angles 1, 2, 7, and 8, because those are the ones that are outside the parallel lines. These are also congruent and are congruent, so you should add that to your definition. And now we're talking about angle 1 being congruent to angle 7, and angle 2 being congruent to angle 8. So 1 and 7, opposite or alternate and their exterior, and 2 with 8. Corresponding angles are angles that are in the exact same position on the parallel lines in relation to the transversal, and these are also congruent. And the best way to describe this is if you look up at the top at the angles 1, 2, 3, and 4, and you look down at the bottom at angles 5, 6, 7, and 8, you can kind of see how I started by numbering in the upper left, and I went clockwise around. So same thing down here. I started number 5 in the upper left, and then I went clockwise around. So each angle that's in the same position is what we call corresponding. So I'm going to use a little bit of a highlighter here. I think this will work a little better. So angle 1 is congruent to 5. Angle 2 is congruent to 6. Angles 3 and 7 are congruent. And then finally angles 4 and 8. And I'm going to mark that down here on our notes. So I'm going to have to write really small here, but so angle 1 is congruent to angle 5. Angle 2 is congruent to angle 6. Angle 3 is congruent to angle 7. And angle 4 is congruent to angle 8. Those angles are in the same position. So 1 and 5 are kind of the upper left, 2 and 6 are the upper right, 3 and 7 are the lower right, and 4 and 8 are the lower left. So these are really important definitions that you need to familiarize yourself with. So let's do another example. You'll see here I have a set of parallel lines. A and B are parallel, we're told in the directions, and Q and R are transversals. So now we need to answer the following questions. Number 4 says, and I'd like you to draw this figure in addition to writing out the questions. So angles 3 and 5. If we look at 3 and 5, they are inside the parallel lines A and B, and they are opposite one another. So they are alternate interior angles. Next, we're given an angle measure. Angle 1 is 120 degrees. So we need to find the measure of angle 5 and the measure of angle 3. We know from above that 5 and 3 are going to be congruent. So all we need to do is find one of them and we can find the other. There are several methods to go about this. So we can start by comparing 1 and 3. Remember from the first set of vocabulary terms, 1 and 3 are vertical angles, and vertical angles are congruent. So if angle 1 is 120, angle 3 is 120. So the measure of angle 3 is 120 degrees, and the measure of angle 5 is also going to be 120 degrees. Again, that's because they are alternate interior angles, and those are congruent. You could have also started with angle 1 and angle 5. Angle 1 and 5 are corresponding. Notice they're in the same position around that transversal. And you could have worked that way, 1 to 5 to 3. Next we're going to compare number 6, angles 11 and 15. So if you look at the picture, angle 11 and angle 15. Okay. If we look at the parallel lines with the transversal, 11 and 15 are in the same position. They're both in the lower right-hand corner, so those are corresponding angles. And now we're given the measure of angle 15. We need to find the measure of angle 11. Okay, we just said that they're corresponding, 15 and 11, so that means they're congruent. So the measure of angle 11 is going to be 78.5 degrees. And the measure of angle 9, and we can do this a couple of ways. 15 and 9 are related. Those are what we call alternate exterior angles. And 11 and 9 are related. Those are vertical angles. So they're all congruent. So either way you go, whether you're getting 9 from 15 or you're getting 9 from 11, it's still 78.5 degrees. Finally, we're going to look at an example where we're told the measure of the large angle and we need to find the measures of each of the inside angles. So this says that the measure of angle ABD, and remember that when you name an angle, the middle letter is the vertex. So here we have this big angle ABD, and we know that that entire angle is 164 degrees. So what does that mean? It's made up of two smaller angles. So if we add those two smaller angles together, angle ABC plus angle CBD, we should get 164. Well, ABC is 2x plus 23, and CBD is x. Now we need to combine like terms. 3x plus 23 equals 164. Subtract 23 from both sides. 3x equals 141. Finally, we're going to divide both sides by 3 so that we can find out what x equals. So 141 divided by 3, we get that x equals 7. But remember that we were asked to actually go back and find the full angle measures of ABC and CBD. So all we found is x. So now you're going to plug a 7 in here and there. That one's easy. To figure out what each angle measure is. So the measure of angle ABC is going to be 2 times 7, 14, plus 23, so 37. Oh, whoops, it's not 7. What am I doing? I'm thinking this isn't going to add up right. Sorry. 141 divided by 3 is 47, not 7. So we're plugging a 47 in for x in both of the angle measures. There we go, that makes more sense. So the measure of angle ABC is going to be 2 times 47 plus 23. That's 117. And the measure of angle CBD is x, which is 47. So always remember that once you've found x, oftentimes you need to go back and actually figure out what the angle measures are. Other times I might just ask you to solve for x. And in class we'll work on worksheet 10.1.